Today we're going to look at how to interpret situations and model them mathematically with an equation. Linear, obviously, that's what we've been doing the entire quarter. A lot of you are probably worried that these are word problems and word problems are scary. But if you read the joke here, the very reason this is a joke is because it doesn't really make sense. The thing I want to get across is that word problems, I think, are actually a little bit easier because they do make sense. You have to actually make sense of them, and if they don't make sense, then you probably did something wrong. So let's look at what I mean. What should I do when I set up any equation? Well, the first thing you should do, obviously, is read. What's the situation? You need to make sense of it. So you ask yourself things like, what is it asking me? What is it giving me? Are there any like rates or initial values or anything like that? What more do I need to know? Are there variables that I don't know? What's going to be my final answer? And then you need to ask yourself, does it make sense? Once you've written something down, you need to ask yourself, does this make sense? Can I read it in context like we were with the functions at the end? Does it actually make sense as to what's going on? And would you trust this calculation if you actually wrote this to help you in a real life situation? Would you trust that? If not, then you should probably go back and check a little bit. So first things first, we're going to read. A machine salesperson earns a base salary of $40,000 plus a commission of $300 for every machine he sells. Write an equation that shows the total amount of income the salesperson earns. So what's it asking me? It's asking me to write an equation that shows the total amount of income. So I need to write something that's going to give me the income. Well, what is it giving to me? Let's read through. He earns a base salary of $40,000. Oh, hey, plus, that's an important word, plus a commission of $300 for every machine. So let's make sense of all this information here. I know I get $40,000 base, and then it says plus a commission of $300, plus $300. Is it just randomly plus $300, 40,000, and then plus 300? No, this says for every machine he sells. So if I get 300 for every machine, I would need to add 300 for however many machines I sold. So let's go ahead and multiply that by the number of machines. 300 times however many machines, when this goes from 1, 2, 3, however many machines I sell, I'll multiply by that, and that's how much I'll have to add on. Well, let's put this all together then. If I have $40,000 and then I make 300 for each machine, well, as the question originally asked me, write an equation that shows the total amount of income. That's going to give me my total. So now let's ask ourselves, does this make sense? Can I read it in context? Let's try to read it in context. I have $40,000 plus 300 for every machine will give me the total, my total income. Would you trust this equation if you need it in real life? If this was your salary, you could find this. I would say, yeah, for sure I would trust this if I was trying to find out. Say I sold 10 machines, this is how I would find it. So yeah, for sure. That looks good to me. Let's look at another. Lynn is tracking the progress of her plant's growth. Today the plant is 5 centimeters high. The plant grows 1.5 centimeters per day. So what's it asking me? I need to find an equation that's going to track plant's growth. So plant's growth is going to be my final thing. What does it give to me? It says it's 5 centimeters high and it grows 1.5 per day. So let's write down the information we know. We know that it's 5 centimeters right now, and then it grows 1.5 per day. So that means I've got 5 centimeters, and it's going to grow. So I'm going to add on 1.5 centimeters every single day. So let's go ahead and multiply by the amount of days. Again, because that's going to go 1, 2, 3, 4, whatever. However many days, that's how many times we need to add 1.5 on there. What's that going to give me? That'll give me the height. The plant's height, let's ask, does it make sense? Can you read it in context? The plant's height is 5 centimeters today plus 1.5 centimeters every day. So 1.5 times the amount of days. Would you use this? Would you trust this calculation if you were tracking your plant's growth? I certainly would, because I can read it in context and it makes sense. 5 centimeters, and I'm adding on 1.5 centimeters every single day. That gives me the height. Next, Mr. Thompson is on a diet. He currently weighs 260 pounds. 260 pounds. He loses 4 pounds every month. Write an equation to represent this situation. So what are we tracking? We're tracking his weight. Let's write down what we know. 260 pounds right now. He loses 4 pounds a month. And we need to write something to represent his weight total. So his weight is going to be 260, and I'm losing weight. So is it going to go up from 260 or down from 260? I'm losing, so it's going to go down. So I'm going to take away 4 pounds. And then how many times do I take away 4 pounds? Every month. So I'm going to go ahead and multiply by the amount of months. Again, 1, 2, 3, 4, whatever months. That's how many times I'm taking away 4. So his weight is 260, losing 4 pounds every month. You're starting to see a pattern here. This is y equals b plus mx, right? Here is your starting value, your y-intercept, which is usually your initial value. And here is your slope. That's your rate. Your rate or your slope. And then this is your independent variable. So it seems to follow this pattern each time. I have an initial value. In this case, it's 260. That's what he weighs right now. And then you have a rate. In this case, it's a rate of 4 pounds per month, but negative 4 pounds per month because we're losing it. So negative 4 is your rate. Let's look back at some of the other ones. I've got an initial height, y equals b plus mx. I've got an initial height of 5, and then I've got a rate. It's positive 1.5 every day. That's your rate, positive 1.5, because it grows by 1.5 every day. Let's look at this. I've got an initial value. I start with 40,000, and then it grows by 300 every machine I sell. So again, this is b plus mx equals y. These are all in slope-intercept form. A lot of times you're going to be able to write it in slope-intercept form like that. Sometimes you can't. Sometimes it's going to show up in standard form. What is standard form? We learned it earlier when we were converting. ax plus by equals c. Sometimes it's going to show up like that. Let's look at a situation where it will. Let's make sense of it. At a school play, children's tickets cost $3 each. Adult tickets cost $7 each. The total amount of money earned from ticket sales is $210. Write a linear equation that relates the number of children's tickets sold to the number of adults' tickets sold. So what's it asking me? I don't know how many children's tickets, I don't know how many adults' tickets, but I know what the cost of each is, and I know what we sold. So children's tickets cost $3, adult tickets cost $7, and we made $210. How would I write an equation for the cost of children's tickets? Well, since they're $3, I would probably say $3 times however many tickets I sold is the cost of children's tickets. What about adult tickets? Well, they're $7 a ticket. So 7 times the amount of adults is going to be your cost of adult tickets. If this doesn't make sense, take the time to stop and think about it. 3 times however many children, that's that's going to give you the cost of children's. 7 times however many adults there are, that's going to give you the total cost. So now that we have this, it's pretty easy to use what's left. We already used this cost and this cost, but we know that we sold $210 worth. So let's go ahead and write that. The cost of adult tickets and the cost of children's tickets, and we're going to need to add those together, will give us the total cost, which we know is $210. Again, this is ax plus by equals c. This is standard form. We've got two different rates here and two different variables. Neither of them is independent or dependent. We just know that it's going to equal 210 in the end. So here's your equation. Let's ask ourselves, does this make sense? $7 times however many adults came, $3 times however many children came, and then we're adding those together. We know that has to equal 210. It makes perfect sense. So you may be intimidated by word problems in the beginning, but as we keep practicing them, all you have to do is ask yourself, does this make sense? What is it asking me? How can I put this all together? And is it going to make sense in the end? If it doesn't make sense, you should go back and recheck your work. You probably made a mistake if you can't read it out in words.